Alright, so today we're going to continue our study of equations and inequalities, and we're going to do so with inequalities with an unknown denominator. Now, when you see an inequality like this, you might be tempted just to multiply by the x, but we can't quite do that because when we multiply by this x, we don't know if it's positive or negative, and as you should already know, when we multiply or divide by a negative number, we have to flip this inequality sign. But for these ones, we don't know if they're going to be positive or negative. So what we can do is instead of multiplying by x, we can multiply both sides by x squared, because what that'll do is that'll get our x off the bottom, and as you know, x squared always has to be positive, because whenever we multiply two negative numbers, we get a positive number. So what we're going to do is we're going to multiply both sides by x squared, and that's going to give us x squared over x is less than 3x squared. So from here, one of these x's cancels with this x, and the right side stays the same. So we get x is less than 3x squared, and we can rearrange this a little bit and get 0 is less than 3x squared minus x. And I don't have to change the sign here because I've just minus my x. I haven't multiplied or divided by x. So now there's two methods we can use from here when we want to solve this inequality. We can find our x values and then test regions, or we can find our x values and then use a graphical representation of this quadratic and use that to solve this inequality. I'm going to show you both methods, and I'm going to explain which one I think is best given different situations. So let's start with graphing this inequality. So I've got my axes set up, and let's rearrange this a little bit. So first of all, I'm going to equate both sides of the equation. And what that's going to do is I'm going to then say 0 equals to 3x squared minus x. So now this is just an ordinary quadratic, and I can solve this relatively easily. And I can do that by pulling my x out of both sides, out of both terms. So I get 3x minus 1. So that implies that x is either equal to 0, because this is just an ordinary quadratic. If this is equal to 0, that whole side is equal to 0, so this inequality works. Or x is equal to a third for the exact same reason, because 3 times a third is 1, and 1 minus 1 is 0. So that's all 0. So now I know that the roots of this quadratic are 0 and a third. So I know that they're going to be at 0, and let's label this as a third. And now if I look here, the number, so my coefficient for x squared is going to be 3, which is going to be positive. So that means that this is a concave up parabola. And that's basically all I need to know to solve this inequality. Because here, I just want to know, the inequality region I want is when this function is bigger than 0. And so the function is equal to the y values. So what this is basically saying is, so if I let that equal to y, I want when my y value is greater than 0. So here, when is y value greater than 0? Well, it's greater than 0 when this blue parabola is bigger than our x values. So it's when it's above the x-axis. That's going to be over here and over here. So that implies that x is less than 0, or when x is greater than a third. And notice that here I'm saying less than and greater than. I'm not saying equal to, because the original inequality was not equal to. All right. So from here, this is the first method. And in general, this is a really good method to use, and it works really well when we've got quadratics. Not so well when we've got harder expressions like maybe a cubic or even a quartic in there. So if we have 2 roots and it's just a nice easy quadratic, we can draw these really well. But the other method, and I'll go stops at about here. So the other method doesn't use this curve. What the other method does is we have to sub in regions and test. So we still equate both sides of the equation and we still get our roots, but from here we test. So we test. And we're going to test on the left, on the right, and in between these 2 points. So a value that's on the left of these 2 points on an axis, so if I have, say, if I draw it on a line and I have 0 and a third, a value that's to the left is going to be, say, -1. And if I sub that into this inequality, I find that we have 3, and -1 squared is going to be 1, -1, so that's going to be 2. So when x equals to -1, inequality holds. And I know that because I end up with 3 minus 1 minus 1, and that's equal to 2, which is bigger than 0, so my inequality holds. And so now I can also test a value in between these, let's say a quarter, when x is equal to a quarter, because that's in between 0 and a third. Then what we get when x is equal to a quarter is 0 is less than 3 bracket a quarter minus a quarter. Oh, that should be squared. So this ends up being 3, and that's going to be 1 over 16. So that's going to be 3 over 16 minus a quarter. So now 3 over 16 is going to be 3 over 16. But when we have our 1 over 4, we're going to change this to 4 over 16 by multiplying the top and bottom by 4. So that means when we minus 4 over 16 from our 3 over 16, we end up with a negative number, which is less than 0, which means this inequality is not true. So when x is equal to a fourth, the inequality fails. So that means that inequality doesn't hold. All right, so now if we look at when x is equal to, say, 1, and we substitute that in, so let's have a look at what that does. So what we get is 0 is less than 3 bracket 1 squared minus 1. So this ends up equaling to 2. So that means we have 0 is less than 2, which is true, which means when x is equal to 1, the inequality holds. Which is exactly what we wanted. So that means that our x values are x is less than 0 because it works down here, and it also works for 1, so it works up here too, and we want x greater than third. But it doesn't work in here, so it's going to end at these 2 points. It is not going to be in here. And this is exactly the same expression as what we got before, which is really good because we would hope that we get the same solution no matter which method we use. Now, in general, this method works. This method is pretty slow when we have quadratics. As you can see, we had to test 3 regions and sub it in and then do it. Whereas the other method just had a simple graph where we only needed the points and the concavity, and we could already determine the region pretty easily. But this method works really well because it's really easy to apply when our questions get bigger and harder, when we have, say, cubics or quartics or just higher powers, or even more complex functions. So this method's really good when we've got really complex things, whereas the other method's really good for something like a quadratic because it's relatively simple. So the first method, what did we do? We went through and found the roots of our inequality after multiplying by a positive number, in this case x squared. And then we drew a rough sketch, and then we figured out our regions from there based on the inequality. And in this method, we did the same thing, except rather than drawing a sketch and then looking at the inequality, we would test the inequality for the different regions we were looking at and see which ones made the inequality true and which ones didn't make the inequality true. All right, so now let's go through this other example. And this one, we're going to do basically the exact same thing, except for this one, we're going to end up getting a quadratic. So I'm going to use the first method. And when we're doing that, I'm going to go through it at the same pace you should be doing it in an exam. So we start with 6 over x plus 3, which is greater than 1. And then, so we multiply both sides by x squared, x plus 3 squared. So times x plus 3 squared times x plus 3 squared. And so from here we get 6 bracket x plus 3 squared over x plus 3. So, and that's greater than x plus 3 squared. So that cancels for that. And so we're left with 6x plus 18, which is greater than or equal to x squared plus 6x plus 9. So I've just expanded that out. And now I'm going to rearrange this. So I get 0 is greater than x squared minus 6 from to get rid of this and get 0 to be minus 6x, and that just cancels. So that'll cancel with that. And then if we also minus our 18 to get rid of it from this side so we can get that 0, then it's going to be 9 minus 18, which is minus 9. And from here, we equate both sides. I'll continue my working up here. So then we get 0 is equal to x squared minus 9, which implies that 0 is equal to, and here this is the difference of two squares. So it's going to be x minus 3 bracket x plus 3, and that formula is on the formula sheet. So that means that x is equal to 3 or x is equal to minus 3. And so if we sketch this parabola, because that's exactly what this inequality is, it's a quadratic, so it's a parabola. So our roots are at minus 3 and 3. And the number in front of the x is positive, so that means that it's going to be concave up. And I want to know when this function is less than 0, i.e. when the y value is less than 0. So that's going to be everything under this curve, so it's going to be everything in this region. And so that implies that x is between 3 and negative 3. And so this is going to be the solution to my inequality. Anything between negative 3 and 3 inclusive this time, because my original inequality is inclusive. So anything between that region is going to give me a solution to this inequality. All right, except for this one, x cannot equal to negative 3. So this one, I'm actually going to exclude negative 3. And why is that? Because if I check the bottom, then here, if I make x equal to negative 3, then I'm going to get 0 on the bottom, which means it's going to be 6 divided by 0, which cannot happen. So for this one, I've gotten rid of this equality because of a restriction here with the denominator of the function. So that's another thing to be really mindful of. In denominators, sometimes we'll get values that we can't have because we can't divide by 0. Over here, that wasn't a problem because we weren't including 0 when we were doing our calculations. That was always not included. But over here, we should be including minus 3, but we can't because of the bottom, and we don't want to be dividing by 0 on that bottom. All right, anyway, I hope that was helpful, and I'll see you guys in the next lesson.